All right, so today we are going to start our new unit. We are going to be looking for, well, we're going to be finding critical points of quadratic equations. Or I should say quadratic functions is probably the more accurate term to use. This is what the unit is called, finding critical points of quadratic functions. We have several units that we're going to be dealing with related to quadratic functions. So next unit, we're going to be solving quadratic functions. So the critical points here, I'm going to explain what that means. We have a few more notes than normal today because it is the beginning of a unit. But the problems that we're going to see today, there's not any calculations that we need to do for today's problems because it is the beginning of the unit. We're keeping things simple for right now. So first off, quadratic function. We've seen these before, but a quadratic function is going to be any function that has x squared. So we could have f of x equals x squared. Nice and simple. That's a quadratic function right there because we have x to the power of 2. All the way up to, we could have something like f of x equals negative 2 parentheses x plus 5 squared minus 9. Right here, yes. Let me make that a little clearer. There we go. So quadratic functions are anything that has an x squared. That x can be by itself squared. That x can be inside of a parentheses squared. We are going to be seeing several different forms of quadratic functions. And I want to talk about those first, but some of those we're not going to come back to for a few days here. So this first one here, this one is called vertex form, which we'll talk about the reasoning here probably tomorrow. We can also have functions that are in what we call standard form. And we'll definitely spend a lot of time with this form in the next unit. So we have x squared plus 5x plus 6. So notice these equations are written differently, but both of them have x squareds. They are still quadratic functions. But this second one, or actually the third one here, is called standard form rather than vertex form. And then the last form that we're going to be seeing is what's called factored form, or sometimes also intercept form. And that's something like this. F of x equals 1/3 parentheses x plus 2 and parentheses, let's say x minus 4. So notice here, this last form is a little bit different than the others because we don't see any x squareds here. We only see two different x's. But if we have x times by x, that will give us an x squared. So if you were to multiply this through, you would end up with an x squared, but it's written differently. And we'll talk about why it's written differently when we actually get to that form in a few days here. So we're going to spend time on each of these forms individually, starting with the vertex form probably tomorrow. But today we are going to look at what the critical points actually are, why they're considered important, and then also how to find them from a graph. So we're going to be using some graphing software in a little bit. We're going to be using some Desmos in order to help us out with the graphs. And then we're just going to be identifying those points from the graphs rather than actually calculating them yet. Tomorrow we'll start calculating them. Let's start looking at what the critical points actually are. So the first critical point, and probably the single most important one, is called the vertex. Now, the vertex is either going to be the highest point on the graph or the lowest point on the graph, but it's going to be where the graph changes directions. So the vertex is the point where the parabola changes directions, and the shape that we are going to be looking at for all of these graphs is the same. It's always called a parabola, and it is the point where the graph changes directions. So what I mean by that is if I have a little graph up here, like so, and I have this U shape, we can see that the graph is going up on one side and then it's also going up on the other side. But if we start going down here and then it turns and goes back up, this point where it turns down here at the bottom, that point is called the vertex. This point at the very bottom of this is called the vertex. We can also have a graph that goes the other direction. So for instance, I could have another graph here. But rather than going up, it's now going down. And so then this point at the top of this graph right here, this point would be the vertex right there. Now with the vertex, one of the things that we have to do is we have to say whether this vertex is a minimum or a maximum, meaning it is either going to be the highest point on the graph and be considered a maximum, or it's a lowest point on the graph and considered a minimum. So if the graph opens up, for instance, this top graph right here, the graph is going up because both of those arrows are going up, then the vertex is the lowest point and called a minimum. So in this first situation right here, we see that the red graph, the red parabola, both of these arrows are pointing up. Therefore, the vertex is down here at the bottom, and we would call that a minimum. That means the smallest possible value. If the graph opens the other direction, if the graph opens down, then the vertex is the highest point and called a maximum. Maximum meaning the largest possible value. So the vertex was the first critical point that we're looking at. With that, we want to be able to identify whether the graph opens up or down. When we say that the graph opens up, we mean that the arrows here are pointing up, the sides are curving up away from the vertex. When we say that the graph is opening down, we mean that these arrows here are pointing down, the graph is curving away from the vertex and going down in that situation there. The next critical point that we want to look at is called the y-intercept. And this is the same point, technically speaking, that that is the y-intercept on a slope-intercept form. So the y-intercept is the point where the graph crosses the y-axis. And with this, there will always be a y-intercept, and there will always be exactly one y-intercept. So let's draw out a diagram here. And my drawings are just not doing good today. You know what? Good enough. So this point right here, that is our y-intercept. Remember, this vertical line in the middle of our graph, that's our y-axis. The one that goes side to side is the x-axis here. But this point where the graph crosses the y-axis in the middle of our graph, that is our y-intercept here. So in addition to the y-intercept, we also have the x-intercepts, and these are the points where the graph crosses the x-axis. And the thing that's different between the y-intercept and the x-intercepts is we don't always have the same number of x-intercepts. We can have two x-intercepts on a particular problem. We can also have one x-intercept, or we could even have zero x-intercepts, no x-intercepts at all. It is possible that our graph does not cross the x-axis. On this graph right here, though, we see that there are two x-intercepts right here where the graph crosses the x-axis. So that's an x-intercept. And then this is also an x-intercept right there. And like I said, the next unit that we are working with, we will spend a lot of time finding those x-intercepts, making sure we can calculate those x-intercepts. But I just wanted to identify what those were for us here today. The last thing that we want to look at is what's called the axis of symmetry. And this isn't a point. This isn't a point, but this is actually a line that we add into our graph. The axis of symmetry is a line that divides our graph in half. It's the line of reflection so that both sides of the graph are the same. And the special thing about the axis of symmetry is it always goes through the vertex, because the vertex is in the middle of our graph. And so the axis of symmetry is very easy to find and identify once we've found the vertex. So we got a parabola here. We know that our vertex is going to be down here at the bottom. But you see how both sides of the graph here are the same? Well, they should be the same. They don't look exactly the same because my drawing isn't perfect. But if we were to draw a line through the middle of our graph right here, I'm going to make it a dotted line. This green dotted line should divide our graph in half exactly. So both sides can reflect onto each other. This green line right here, this green dotted line, this is called the axis of symmetry. And since it always goes through the vertex, it's very, very easy to find once you know what the vertex is. Let's go ahead and take a look at an example problem here. So your directions will be something along the lines of oh, let's not make that green. Let's make that black again. Identify the vertex. Axis of symmetry and the y-intercept, and then determine if the vertex is a minimum or a maximum. So we see that we are asked for several things here, and that's one of the keys on these types of problems is making sure you are actually answering everything that's asked for. So we need to find the vertex. That's one thing. The axis of symmetry, that's 2. The y-intercept, that's 3. And then lastly, say whether we have a minimum or a maximum. So there's basically 4 things that we need to find on each of these problems. As we go through this unit, we are still going to be finding those exact same things. Every problem in this unit is basically going to be asking for the same things. The only difference is the information that we start with. Today, we're going to be graphing these to find our information, but we will be calculating based on the different forms that we had seen at the beginning of class. So here, let's just start off with a problem in vertex form here. All right, so if we have a problem in vertex form, that's going to be like this. F of x equals, let's say, x minus 2 squared, and then minus 3. And some of you might be looking at this thinking, okay, he just mentioned that we're going to graph this. I don't know how to graph this. That's okay. We're going to use graphing software to help us graph this out. So if you want to go ahead and pull up your laptops or pull up your phones, the website that we're going to be going to is desmos.com. Sure. All right, so once you get to Desmos, it'll look like this, and we are going to be using the graphing calculator here. There's also a very wonderful app for Desmos that you can get for your phones, and that's honestly what I use for my calculator 90% of the time. And so then we get this very wonderful graphing system that we have here. And all I need to do is type in the problem exactly like I wrote it out. So I'm going to type f parentheses x, or f of x, equals, and in this case, parentheses, x minus 2, close parentheses. Now I need to do a squared for this. So what I'm going to do is I'm going to come down here to this little keyboard, and I'm going to click Show Keypad, and we see that there's a squared button right there. And then I finish with the minus 3. Now you can move this around by clicking and dragging. You can zoom in and zoom out, but for right now, there's not really any need to do that. Now, here's the wonderful thing about Desmos is Desmos knows that these particular points we were just talking about are important. And so it will automatically calculate these points for us. So if you have accidentally unselected your graph or you have clicked somewhere else, you can click back on the parabola. And notice we have some of these points appear on the parabola in various places here. So notice down here at the bottom where we know our vertex is, there's a gray dot right there. If I hover over that gray dot, it will tell me that my vertex is the point 2, -3. It calculated the vertex for us. It found the vertex for us. Notice here, this +2, -3 actually corresponds to the transformations we had talked about in the last unit. If we have a -2 inside the parentheses, that moves our graph 2 spaces to the right. Our graph is moved 2 spaces to the right here. If we have a -3 on the end, that moves our graph 3 spaces down. And just like we had described, that moves our graph 3 spaces down. So the vertex is +2, -3, and we can get that very easily from Desmos because they automatically calculate that information for us here. So if we go back to our problem, we can identify our vertex here. As +2, -3. Now we also needed to say whether this vertex was a minimum or a maximum. So in order to figure that out, let's go back. It was a minimum. Why was this a minimum? Right, so our graph here is opening up. Notice these two sides of the graph are going up away from the vertex. So that means that if the graph is opening up, the vertex is down at the bottom. And when the vertex is the lowest point, we call that a minimum. So we want to say that with our vertex that we had just labeled. The vertex is a minimum since the graph opens up. And I would appreciate that explanation there as to why it's a minimum, because I think writing that out is going to help you understand that connection. Now, also related to the vertex was the axis of symmetry. So that's what we'll look at next here. So I said that the axis of symmetry always goes directly through the middle of our graph. Well, if I'm looking directly in the middle of the graph, that's the vertex right here. And we are looking at the x value of the vertex. Well, the x value is the first number here. So I have the point, I have the number 2 right there. And for the axis of symmetry, it's always x equals whatever number that is. So if I type in x equals 2 into Desmos, I see this nice blue line right through the middle of my graph right here. That is the axis of symmetry. That is the line that divides our graph in half. That is the line where the graph reflects on itself. So we can add that in with our answer here. We can say the axis of symmetry is x equals 2. And it's always x equals the x value from the vertex right here. We do have to include the x equals. If you just say the axis of symmetry is 2, that is not entirely correct, because x equals signifies that it's a vertical line. If you had y equals 2, that would be a horizontal line. And so you have to specify that the axis of symmetry is an x equals equation. The last thing that we want to find here is the y-intercept. And remember, the y-intercept is the point where the graph crosses the y-axis here. So if I click on my parabola, I see that this point right here is where my graph crosses the y-axis. And once again, using Desmos, I can just hover over it. And I see that that's the point 0, 1, 0, +1. That is my y-intercept. For what we're doing today, we don't need to calculate this ourselves. We're going to use Desmos to help us out. We're going to use Desmos in order to do those calculations for us. So that's what I want to include on my answer. So I'm going to say the y-intercept is 0, 1. And so this is everything that we have been asked to find. We were asked to find the vertex. We found the vertex here. We were asked to find the axis of symmetry. We've got the axis of symmetry right here. We were asked to find the y-intercept. We've got the y-intercept. And lastly, we were asked to determine if the vertex was a minimum or a maximum, and we did determine that it was a minimum right here. So like I said, these 4 things are going to be the 4 things that we're finding on just about every problem in this unit here. Questions on how I found these, questions on what I was doing. All right, so for you all to try, let's have f of x equals x squared plus 4x plus 4. So this is in a different form than the last one that we looked at, but you still graph it out the same way in Desmos. You're still going to type this function into Desmos, just like I showed you. Even though it's in a different format, it'll still make the same type of graph here. All right, so if we go ahead and graph this out, go ahead and graph this out as I clear things out. Then we have f of x equals x squared plus 4x plus 4. Oh, I did have it on freeze. Thank you. And so our graph should look like this. So if we're looking here, our vertex is going to be this point down here at the bottom, -2, 0. Now, is this vertex a minimum or is this a maximum here for this problem? What do you all think? Is the vertex the lowest point on the graph or the highest point on the graph? It's the lowest. So our vertex here is a minimum. We can also use the x value of our vertex right here in order to make our axis of symmetry. And in this case, we have -2. So our axis of symmetry will be x equals -2. And we see that makes a nice vertical line right through the middle of our graph here. If for some reason you type things in incorrectly, let's say you wrote +2 instead of -2, and you end up with a line that is not in the middle of our graph, you know that that is not correct. We need to have this line right through the vertex, right through the middle of our graph. So make sure that it ends up right there. So our axis of symmetry will be x equals -2 in this case. We always just take the x value from the vertex for that axis of symmetry. Lastly, we need the y-intercept. And once again, if we click on our parabola, we should be able to come up here to this point, and we see that this point is the point 0, 4. So our y-intercept oh man, I did not realize that. Okay, so I can't actually type that out right there. We're going to go back. So we said that our vertex here was the point -2, 0. We said that the vertex is a minimum since the graph opens up. The axis of symmetry is x equals -2 because it's the x value from our vertex. And the y-intercept is the point 0, 4.